Welcome to The Explainer. So I want you to picture something with me for just a second. Imagine we're standing right in the middle of a neon-lit holographic lab. The hum of servers is buzzing all around us, and you've got these screens just floating in the air waiting for our commands. Today, I'm going to be your enthusiastic mentor in this digital space, and we've got a very specific, highly practical mission ahead of us. We're diving into Episode 6 of the Ethical Hacking Masterclass, and we're looking at a tool that absolutely changes the game for cybersecurity professionals. So let's dive right in. We're going to master a tool that quite literally turns the invisible visible.
How do you see in the dark? I know, it sounds a bit like a riddle, right? But in the world of computer networking, this is a very real, very literal problem. Because when you plug into a network, you don't just magically get handed a map of every single device, server, and router connected to it. By default, you're completely blind. It's like you're standing in a pitch-black room. You have absolutely no idea if you're alone, if there are 100 servers sitting right next to you, or what doors might just be left wide open. Without the right tools, network blindness is your default state, and obviously you can't secure what you can't see, and you certainly cannot test it.
Section 1. Navigating the Digital Ocean. The Unseen Network.
You know, trying to figure out a network without specialized equipment is exactly like swimming blindly in a pitch-black digital ocean. You're swimming around surrounded by these massive structures, databases, web servers, firewalls, but they're all entirely submerged in the dark. You could bump into a massive vulnerability and literally never even know it was there. So to map this unseen digital ocean, ethical hackers reach for Nmap, which is short for Network Mapper. It's a completely free, open-source utility used for network discovery and security auditing. And honestly, Nmap is legendary. It's the foundational, ultimate tool built right into operating systems like Kali Linux. It is the absolute first thing an ethical hacker reaches for when they need to understand their environment. Because it doesn't just tell you that a computer exists on a network, it tells you exactly what that computer is doing. But how exactly does a simple command line tool pull that off?
Section 2. Nmap, your submarine sonar, pinging the void.
Okay, this is where it gets really fun. I want you to completely wipe away the idea of just typing boring lines of code into a terminal, and instead, think of yourself as a submarine captain using Sonar. You're sitting deep in the dark depths of the ocean. To figure out what's around you, you use Sonar to send a sound wave out into the pitch-black water, and you just listen for how it bounces back. That is exactly what Nmap is. Step 1. Send the packet. This is the ping. You're firing these beautifully crafted tiny packets of data out at target IP addresses into the void of the network. Step 2. Wait for the echo. When those packets hit a target system, that system's built-in rules basically force it to reply in very specific ways. And Step 3. Map the target. By analyzing exactly how those packets bounce back, Nmap's engine translates those raw digital echoes into a highly detailed map of your surroundings.
Section 3. Decoding ports in systems. What the echo tells us.
So the absolutely crucial point here is that not all echoes are the same. The data returning from our digital sonar pings contains vital structural secrets about our target. Think of a computer on a network, kind of like a massive house with 65,535 different doors and windows. Yeah, that many. These are called ports. Each port is designated for a specific type of traffic, like web browsing, emails, or file transfers. Nmap's job is to go up and knock on every single one of those doors and listen to who or what answers. When Nmap knocks on an open port, the door is unlocked, and a service running inside sends back a specific, welcoming response. It essentially says, "Hello, I'm a web server, come on in." But if the ping hits a closed port, it encounters a locked door or a firewall, and it violently bounces off the hull. The system replies with a sharp, "No one is home, go away." By contrasting these two very different types of echoes across thousands of ports in a matter of seconds, Nmap starts to draw a clear picture of the target's perimeter.
And Nmap gathers just a staggering depth of intelligence. It doesn't just stop at finding open ports. By using specific scan flags, Nmap actually analyzes the subtle quirks in the echo to determine the operating system. If you toss in a $O flag, for instance, that can tell you if the target is running Windows, Linux, or maybe some old version of Mac OS. It uncovers service versions too. Using a -SV flag means it doesn't just know a web server is running, it knows it's specifically running Apache version 2.4.49, which, by the way, might have known vulnerabilities. And finally, device types. Is it a server, a laptop, a random network printer? Nmap takes all of this data and builds a complete 3D holographic map of the target system right there in your terminal.
Section 4. The Metasploitable Sandbox. Establishing the boundaries. Okay, I need to shift my tone here for a second. We've talked about the incredible power of this digital sonar.
But with great power comes a massive, absolutely non-negotiable responsibility. We're stepping out of the theoretical and into the practical right now, which means we need to establish some strict boundaries. You literally cannot just take Nmap and start firing pings at whatever you want on the internet. We stick to legal targets. In our masterclass environments, we use things like Metasploitable, which is a virtual machine intentionally built to be vulnerable so you can practice your skills safely. We use authorized virtual labs like OWASP Juice Shop or DVWA. These are safe, isolated sandboxes. Pointing your digital sonar at illegal targets, like real-world websites, your neighbor's Wi-Fi, or random company networks, is strictly off-limits, no exceptions.
Scanning without permission isn't exploration, it's a crime. This right here is the hacker code, and it is the absolute foundation of our field. If you run a detailed Nmap scan on a corporate network without written permission, you are not a curious student. In the eyes of the law, you are a malicious actor conducting reconnaissance for a cyber attack, and the consequences for that are incredibly severe.
Authorization is everything. I really want to let this sink in. Authorization is the single defining difference between an ethical hacker, a highly paid, highly respected professional, and a cybercriminal facing prison time. The tools we use are exactly the same. Nmap doesn't judge. Kali Linux doesn't judge. It is the permission slip in your hand that determines what side of the law you are on. So always have authorization.
Section 5. Your first Nmap mission. Firing up Kali Linux.
All right, let's bring that energy right back up. Now that we know the rules of engagement, it's time to take your new knowledge straight into the lab. We're going to step into our authorized, isolated network and put our own hands on the controls. It's time to see what this digital sonar actually looks like in action. So, here's the checklist to run your very first legal scan. First, you boot Kali Linux, your primary hacker operating system. Second, you launch your Metasploitable sandbox. This is your target, safely running in a virtual machine right on your own computer. Third, you open a terminal and execute your target IP scan using Nmap. You type the command, fire those pings into the dark, and wait. And finally, you analyze the digital map. You just watch as the terminal populates with open ports, operating system guesses, and service spanners. You are finally seeing the network in high definition.
So now that you can see the open doors in the dark, what exactly is your next move? You've successfully mapped the network. You know the operating system. You even see an outdated web server running on port 80. Nmap has done its job beautifully, acting as your eyes in the digital ocean. But discovery? That's really only the first phase of ethical hacking. Once you map the target, how do you actually secure it? Or, if you're testing defenses, how do you exploit it? That is the incredible journey we have ahead of us. Thanks so much for joining me on this explainer. Keep learning, stay ethical, and I'll see you next time.